Hello, this is checkpoint 6.32. They want us to calculate this line integral where f is sine x sine y comma 5 minus cosine x cosine y, and c is a semicircle with the starting point 0 pi and ends at 0 negative pi. Now, normally they would specify the orientation, or no, I guess they do specify the orientation because they have the starting and ending point. Actually, they don't tell us whether it's the top half or the bottom half. Um, so I guess they don't have um, our parameterization in mind here. But in any case, we can say that this is a semicircle is 0 comma pi. Let's say pi is up here, 0 comma negative pi. Negative pi is down here. Semicircle, it could be starting at this point. They don't say if it's clockwise or counterclockwise, but if it was counterclockwise, we'd be going this way, or if it's clockwise, we'd be going the opposite way. In any case, it doesn't look like it's that part's given, so we're hoping that we can actually use the fundamental theorem of line integrals here. And that'll depend on whether our vector field is actually a gradient field or conservative or path independent and all that. If it is path independent, then we know that given our start and endpoints, we can just use the potential function to evaluate the integral. All right, let's first check if it's conservative. Check if f is conservative. And we can check if something's conservative by taking our p function and our q function. Partial of p with respect to y, is that equal to partial of q with respect to x? Question mark. So let's take the partial of p with respect to y. The derivative of sine is cosine. So this would be sine x cosine y. And now we take the derivative of q with respect to x. And so the derivative of 5 is 0, derivative of cosine is negative sine. So this would be negative sine, negative, so that make that a positive. Negative sine x cosine y is constant with respect to x. And yes, they are equal to each other. So check if it's conservative. That is conservative. Now let's find the potential function. Find potential function. And we'll do that by assuming that this is fx and fy and finding the antiderivatives. So f could potentially be the antiderivative of fx with respect to x, which is sine x sine y with respect to x. Now that is constant. Y sine y is constant. The antiderivative of sine x is negative cosine x. And we want to allow for constants with respect to y, because the derivative of something with a y in it with respect to x is 0, so that might have disappeared. And similarly, we will take our second function and assume that that's a derivative with respect to y, so we'll take the antiderivative of that with respect to y. And our second function is 5 minus cosine x cosine y. And we'll do this with respect to y. The antiderivative of 5 is 5y. The antiderivative of cosine is in positive sign, so the negative stays. cosine x sine y. And then we want to allow for a function of x because that might have disappeared. All right, so we have a gy and a y, a function of y here that probably could correspond. And then we have the function itself agreeing with a negative cosine x sine y. So it looks like our potential function f of xy is equal to the 5y minus cosine x sine y, and a constant if you want, but we'll just go with this. And then finally, now that we found a potential function, we can use the fundamental theorem of line integrals, which tells us that fundamental theorem of line integrals tells us that antiderivative of a conservative vector field, let's just call it a gradient field, dr is equal to the function itself, which we just found starting at the evaluated at the endpoint, minus the function itself at the start point. From here, let's remember that the start point is 0 pi. Start point 0 comma pi, and then the end point is 0 comma negative pi. Therefore, we're going to have your integral here is going to be the function evaluated at the end point first, which is going to be a 5 times negative pi minus cosine of 0 sine of negative pi minus the function evaluated at the start point, which is 5 comma pi minus cosine of 0 sine of pi. Turns out that the sine of pi and negative pi are both equal to 0. So we have a couple of zeros there. And what we have left is negative pi, negative 5 pi for the first term, and minus 5 pi. So negative 10 pi is your final answer. All right, I hope that helps.